Everyone, Mr. Hissner here, and today we are going to just jump into the meat of the potato. We are going to look at angle proofs. So we're going to use our definitions, our postulates, our theorems with angles and prove some conclusions about those things. So let us look at our first proof. So what I will always do is I will always have a discussion about the proof before I start the proof, and I will require you all to do the same. So here is my discussion. So let's see what we have here. We have that BE bisects ABD. That BE is a bisector. So what do I know? I'm just going to label this 1 and 2. So I know that the measure of angle 1 is going to be equal to the measure of angle 2. And these are also going to be congruent. These are going to be congruent. So this is the definition of a bisector. The bisector is making these two angles the same. And then how I'm going from here to here, this is the definition of congruence. So just kind of getting my thoughts in a row here. Okay, that is the bisector. Let me see, definition of bisector. Oh, we have another one here. We have BD bisects. So we're going to have the measure of angle 2 is going to be equal to the measure of angle, let's just call this one over here 3. Okay, so I'm thinking, well, this is again definition of bisector. All right, well, oh, I see it already. If I see it, I'm just going to put it over here. So we have two bisectors, right? So we know the measure of angle 1 is equal to the measure of angle 2. We know that the measure of angle 2 is equal to the measure of angle 3. And so we know that this is the transitive property. We know that the measure of angle 1 is equal to the measure of angle 3, and thus those things are congruent by the definition of congruence. And let me just look at my proof here. That does look like the way that this is going. So if I kind of zoom in here, we have bisector, which is given to us. The angles are congruent. That's what the bisector is. That's the definition of a bisector. We're given another bisector. That's this one here in yellow. And again, those two things are congruent, and thus these two things must be congruent. So I'm looking at angles 1 and 2 are equal. Angles 2 and 3 are, congruent rather. And then thus angle 1 is congruent to angle 3. So that's literally the transitive property. Yeah, and that is going to be how this proof shakes out. So let's see. This is our given information in green. That's not the word given. That's the word given. And then this is angle 1 and angle 2. So the reason these two ABE is congruent to angle EBD, that is literally what the bisector is doing. That's the definition of an angle bisector. Okay, and let's look. So this is again some given information. And again, let's see. EBD is congruent to DBC. Again, this is literally what the bisector is doing. It's making these two angles congruent. So that is what the bisector does. And now, really, we're just using the transitive property. As I kind of simplified to the right here, this is the transitive property, right? We have angle 1 is equal to angle 2. Angle 2 is equal to angle 3. So A is equal to B, B is equal to C, then A is equal to C, or the congruence is the same, or the angles are congruent, right? Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. This is the transitive property of congruence right here. But really, you don't need to write all that. This is literally just the transitive property. Very similar to how we would wrap up a lot of segment proofs, really. Transitive property is perhaps the most important property when doing proofs, really. It makes you, makes the user be able to draw grand conclusions. And that's why so typically it's used either at the very end of the proof or indeed to finish the proof. And that's what I got for this one. So you will have an example very similar to this. Thanks for watching.